Hi everybody, today we're going to talk about transformations of graphs of sine and cosine. My goal is to talk about vertical shifts, phase shifts, amplitude, and period. We'll go through all of these transformations in this video. I'll add an extra video with more examples if you want to see more. In our last video, we looked at the basics of graphing sine of x. We took points from the unit circle and we put them onto the xy axis. Today, to make things easier, we won't use as many points, but we'll still see the basic sine curve in our graph. We'll focus in on the max, the min, and the intercepts of our curve. We'll do the same thing with the cosine function. Instead of using all of our points from the unit circle, we'll focus in again on the max, the min, and the intercepts. As we work on the graphs of sine of x and cosine of x, we will see the basic way that we express the function will change. Today we'll look at f of x is equal to a times the sine of bx minus c plus d. We will also look at f of x being a times the cosine of bx minus c plus d. Our job is to figure out what a, b, c, and d do to the basic graphs of sine and cosine. To start us off, I'm going to look at the graph of sine of x. And I want to show you what happens if we graph the sine of x plus d. As d increases, you can see that the graph moves up. If I make d negative, you'll see that the graph moves down. Notice that I've added a horizontal line through the graph. This line is called the midline. It stays in the middle of the high and the low of the function. This shows that when we add d to either the sine function or the cosine function, that we get a vertical transformation. D moves the graph up when d is positive and down when d is negative. The midline of a function is the line that is between the maximum and minimum points of the graph. It occurs at the line y is equal to d. Let's give that a try by graphing f of x is the sine of x plus 2. I'm going to label that d is equal to 2, which means I have a vertical transformation up 2 units. I also know I have a midline at y equals 2. I'm going to start by drawing in that midline. I'm going to put it in as a dashed line. Then I'm going to think about the sine function. Sine usually starts at 0, but because we added 2, we're going to go up to 2. At pi over 2, we're at 1, but if I add 1 plus 2, I'm at 3. At pi, I should be back on my midline. At 3 pi over 2, I should be 1 under. At 2 pi, I should be back to the midline again. So I use my midline as my reference point. We could continue this pattern of going above, back to the midline, below, back to the midline. Then we connect the dots to see our curve. Let's try the same thing with the cosine of x. In this case, d is equal to negative 3. That says our midline will be at y equals negative 3. I'm going to start by putting my midline at negative 3. Then I want you to think back to cosine. Cosine starts above the x-axis, so we want to start above our midline. So we're going to go 1 above. At pi over 2, we're back to the midline. At pi, we're under the midline. At 3 pi over 2, we're on the midline again. And at 2 pi, we're above. We could continue to go down, down, up, up, and then connect the dots. The next transformation we're going to look at is amplitude. Amplitude is the stretching or shrinking of our function. It comes from having a coefficient of our sine of x or cosine of x. Here I've graphed cosine of x. If I increase the value of a, cosine of x stretches. We can see the max gets higher, the min gets lower. Notice that our intercepts don't change. If I make a smaller, you can see the shrinking. And if I make a negative, you can see there's also a reflection. The absolute value of a is the amplitude. Notice that we say the amplitude is always positive. When you have a negative sign in front of the a, we say that's a reflection of the graph. Again, let's give that a try. Let's graph f of x is equal to 2 times the sine of x. For this function, the amplitude is equal to 2. Our sine starts at 0, then our max, instead of being at 1, will be at 2 times 1, which is 2. We'll come back to 0 at pi, then we'll go to our minimum. 2 times negative 1 is negative 2. We return back to 0, up to 2, down to 0, down to negative 2, back to 0. So we see this overall stretching of our graph by adding in an amplitude. If we have f of x is negative 3 times the cosine of x, we'll start by saying the amplitude is equal to 3. I want to stress the point that amplitude is always positive. The negative tells me my graph's going to reflect over the x-axis. When I go to graph negative 3 times the cosine of x, I'm going to start at negative 3 under the x-axis. I'll go to 0 at pi over 2, positive 3 at pi, back to 0 at 3 pi over 2, and negative 3 at 2 pi. I can continue this motion over my graph and then connect the dots. Let's switch this around and find the function graphed. I'm going to start by finding my midline. What I notice is that I have a minimum at negative 1 and I have a maximum at positive 7. If I look at the distance between the maximum 7 and the minimum negative 1, I find that that's a distance of 8. If I divide 8 by 2, I get 4. So I expect the midline to be a distance of 4 units from both the maximum and the minimum. Looking at 7 minus 4, that tells me 3. Or if I do 4 plus negative 1, I also get 3. I'm going to draw in my midline at y equals 3. I'll also write that as a note that the midline is y equals 3. This immediately tells me that d is equal to 3. The distance of 4 that I can see between the midline and the maximum, or the midline and the minimum, tells me my amplitude. So I have a is equal to 4. The last thing I want to do is decide which kind of graph this is. Do I have the sine of x or do I have the cosine of x? How you decide is by starting at 0. At 0, I can see I'm up at 7, which tells me I'm starting with the cosine. So my function f of x is equal to 4 times the cosine of x plus 3. Our next graph states that f of x is equal to the sine of 2x. If you look between 0 and 2 pi, you can see that we have 2 full periods of sine. This shows us that we have a whole period of sine and the horizontal distance of pi. This should feel like a compression of the sine wave. Sine and cosine both have a period of 2 pi when we look at their basic functions. When we take f of x as a times the sine of bx minus c plus d, or f of x equals a times the cosine of bx minus c plus d, we find the new period by dividing 2 pi by the absolute value of b. For our last function, f of x equals sine of 2x, we would find the period by taking 2 pi and dividing by 2, which gives us pi. Let's find the period for f of x is equal to cosine of a half of x. To find the period, we'll take 2 pi and we'll divide by 1/2. Remember, when you divide by a fraction, you multiply by the reciprocal. This says our period would be 4 pi. Let's graph f of x equals the cosine of negative 2x plus 1. 1 represents our vertical transformation, that we will go up 1 unit. It tells us that we have a midline at y is equal to 1. When we look at the cosine of negative 2x, it will be equal to the cosine of 2x because cosine is an even function. This shows us that our period will be equal to 2 pi divided by 2, which is pi. I'm going to start by drawing in my midline at 1. Before I draw my points on the graph, I'm going to look at the period pi and I'm going to divide it by 4. This shows me where I should have my max, my min, and my intercepts. So starting at the midline, I should go 1 up to get my max. Then at pi over 4, I should be at the midline. At pi over 2, I should be at my min, which will be at 0. At 3 pi over 4, I'll be on the midline again. When I get to pi, I'll be back to the max. When the period changes, the points where the max and the min occur will change as well. Let's put in one more period of cosine. So go back to the midline, back to our minimum, back to midline, back to our maximum. Our last transformation is called a phase shift. When we've graphed other functions, we would just call this a horizontal transformation. That shows us we can move to the right, we can move to the left, but the graph isn't changing otherwise. The phase shift is found by setting bx minus c equal to 0. When your result is positive, it says we move to the right. When your result is negative, it says you move to the left. Now that we've covered all of our types of transformations, let's take the function f of x is negative 5 times the cosine of 4x minus 2 plus 3 and find the amplitude, period, midline, vertical shift, and phase shift. We'll start with the amplitude. The amplitude is equal to the absolute value of negative 5, which is 5. To find the period, we take 2 pi and we divide it by the value of b, which is 4. This is our period is pi over 2. The midline will be equal to y equals 3, which says we have a vertical transformation up 3. The phase shift comes from taking 4x minus 2 and setting it equal to 0. This says 4x is equal to 2, which says x is 2 over 4, which is 1/2. We will move to the right 1/2. Now that you've seen the basics, you're ready to move on to the next video that does more examples.